everyone. Welcome to today's InfoQ Live Roundtable. In this session today, we're going to chat about DevOps modernization. We're going to talk about agents. We're going to talk about so-called intelligent observability and automation. But before giving the chance to our panelists to introduce themselves and start the discussion, I'd like to just give a couple of housekeeping rules. First of all, we are scheduled to go for about 60 minutes. We'll begin with a discussion featuring between our panelists, but there will be a lot of opportunity for you to ask questions. Don't be shy. You can ask questions whenever you want. Don't wait the end, just till the end. Ask at any time. I will make sure to bring the question from the attendees to the panelists. With that on, I would like to finally thank Arnes for sponsoring today's session. And just a couple of words about today's topic before starting the discussion. Of course, nothing surprising here. AI is changing DevOps, and it's changing the way teams are moving beyond, well, reactive monitoring towards predictive automated delivery and operations. What does that mean? Well, how can team actually implement predictive incident detection, intelligent rollout, and AI-driven remediation with the idea, and almost all, how can we accelerate as well delivery? Well, those are all topics that today's panelists hopefully are going to cover. So my name is Renato Losio. I'm by day a cloud architect, mostly working with cloud technology, AWS stuff. I'm an editor here at InfoQ, and today I'm joined by 4 different experts coming from different industries, different backgrounds, and they will discuss how agents and generative models are being integrated into pipeline, but not only in platform engineering, feature management, observability. But I would like not take further time from them, and I'd like to allow each one of them to introduce themselves and share their journey in DevOps modernization. So, well, let's start with, I don't know, Patrick, do you want to go first?
Sure. My name is Patrick Debois. You might know me from 2 things in the industry, which is the DevOps Handbook and DevOps Days. We kind of sparked a little bit of the DevOps thing. I'm now like 2.5 years into more coding with AI. So I left a little bit of the ops side, but I'm still keeping an eye on what is happening in ops, because there's obviously a close relation to that. I currently work as a product dev role at Tessel, where we're trying to solve some of the delivery problems of context. That's me.
Thank you, Patrick. Mallika, you next.
Thanks, Patrick. Hi, you all. I'm Mallika. I have led platform and infra teams at Netflix, Twitter, Walmart in the past, mostly with a background in search, personalization, and recommendation systems. And I came into DevOps through a very large-scale distributed systems lens rather than tooling-first automation. And my teams sit at that intersection of innovation, reliability, migrations, and developer velocity even. So I'm really interested in how AI helps teams reason faster about complex systems, not just automate tasks, because at this intersection of reliability, migration, innovation, small mistakes have massive customer impact is how I've seen. So very much looking forward to the panel discussion today.
Thank you, Mallika. Lekan, do you want to give a short intro about yourself?
Yeah, sure, of course. So my name is Lekan. I'm a VP of engineering at HRS Group, leading multiple teams, and also recently transitioned into platform engineering, responsible for the production reliability and also setting the standards when it comes to engineering. At the same time, or in my free time, I'm an AWS machine learning hero, which then leads to usage of AI and maybe setting the standards on the use of AI with the teams and also across the teams that I work with in HRS. Maybe for me also, I have a small background in product management. So in case you'd see me talking about product management, it's not, don't be angry. It's just the fact that we need to wear product hats a lot of times as engineers.
Thank you. Like, Martin, you're last one of our panelists to introduce.
Sure, no problem. Hi, I'm Martin. I'm a field CTO at Harness, where I've been here for a couple of years now. Prior to that, I've had 30 years of building, delivering software, and kind of, I guess, the last 12 or so of that before I joined Harness was kind of running DevOps, migrating products into cloud, and ultimately building out platform engineering teams. Now I'm much more focused on helping teams modernize their software delivery, doing that through a variety of ways. And I don't want to steal the thunder of the whole thing, but a lot of what we're going to talk about today is what I spend most of my time doing.
Thank you, Martin. I've actually thought a lot about today's topic, and because I'm actually managing myself some production environment, I put my SRE hat some time on, and actually I've been thinking there's a lot going on, of course, in terms of AI and modernization of the entire space. But one thing I've always looked is where actually, if I think today, where does human attention get wasted? I mean, what's the part where at the moment we are spending most of our energy? I don't know who wants to go first. Patrick, maybe?
Wow. Well, we had this idea within DevOps that we would automate a lot of things. And by doing so, it becomes a repeatable thing. But like you said, part of that is also reducing the cognitive load of doing certain things and not having to waste our time on that. Now, I still see a lot of there's a failure in production and let's dig in and kind of do a lot of things. I think AI can help us surface and reach kind of more into the depth of sources, like where it's supposed to happen. So a lot of that toil kind of can happen. And another thing that I often see, and then that's maybe like, as another example in bigger outages, there is obviously the triage. There is kind of like summarizing things, but there's also a communication burden to the outside if you have like a large impact on that. And so all of these things can be actually improved with the assistance of AI to do that. And I'll let the others chime in maybe with some other cases.
Thank you, Martin. Thank you, Patrick. I see Mallika actually nodding. I don't know if you wanted to add something.
Yeah, no, I completely agree with Patrick. I do feel like human attention is mostly wasted on triage without context, especially. Engineers spend enormous amounts of time answering questions like, is this signal real? Is it new? Is it customer impacting? Right? So that waste isn't just investigation, it's that uncertainty around what is happening. So I feel like AI is most valuable when it collapses ambiguity early, so humans can actually focus on decision making and not just that data wrangling. So it's less about the fact that alerts are noisy. They could be at that stage, but it's also that ambiguous uncertainty at that stage is the real tax that teams pay. So, yeah.
Thank you, Mallika. I actually wonder what is I feel that pressure myself with alert and failure, and is something that we tend to almost all over time. I'm thinking how I build everything over time and go from a few monitoring emails per day to a few hundred, a few thousand, to then try to find a way out of it and hope that AI is going to sort out everything for me. But actually, I wonder, when I look at what's the first real problem AI should help in DevOps today? I don't know, Martin, what's your feeling there?
The first, I know, I think there's a couple, but I mean, it, it's going to be a little bit different for every organization, I would say. But I think echoing some of what we just heard, turning those kind of raw signals that you get into something contextual, that's meaningful and understandable. I think though probably the easiest thing, and I say this from experience, is just eliminating some of that kind of low level toil that often happens around some of the things that we do when we're delivering software. Whether that's, it doesn't matter how good your pipelines are, you still get failures, and trawling through logs and things like that is painful. AI is great at doing those kind of things and can absolutely, dig into what the failure is and probably tell you how to remediate that failure, rather than you trawling through all those logs to find the problem. I think also when you have as kind of mentioned, that summarization of changes that's happened when you have an outage. So knowing all the things that have changed in that environment, because almost always when there's a failure in the system, it's due to a change, right? And so knowing what's changed and when and how is kind of critical to making resolving issues and outages easier. I think though, that certainly the approach I took previously that worked really well was just picked a couple of things that really mattered, that actually created a lot of noise, and took those away. So whether that's finding something that just people are spending a lot of time doing, whether that's just sometimes it's just the glue between systems, right? Those scripts that kind of glue system A to system B, and removing those and kind of allowing AI to do that integration, I think is where to start. But like picking those high priority, high noise things and removing them is probably a great place to dig in and remove them.
Thank you, Martin. Lekan, what's your experience in that sense? What do you think is what do you think is the first real problem AI should solve, but as well, what has been for you eventually?
Yeah, so I think it's two-part question, but I would answer what it is for me and what I think AI should solve, or the other way around. I think in general, because when I coach the senior, let's say staff engineers, and also the engineers that work with me on my teams, I usually start with, think of AI as a junior engineer. And what would you not want to do today that you would say to a junior engineer, either DevOps or not, to do? And so that you can spend time on high value work. And usually this is how I start my thinking, right? Let's say there's a failure in production, whatever that is, or failure somewhere. What would I ask the junior engineer to do? And I remember when I started, my coach back then, or my line manager back then, would tell me, this is where to start your investigation. Go through the logs, sift through XYZ to understand what you need to debug, or how you need to debug. And over time, I learned debugging is an art. And then you need to think about it from AI as well. And this is what I ask AI to do, is go sift through the logs in this particular way to understand where to look in the application code. And imagine if a human being has to sift through at least thousands of lines of logs, depending on how connected the systems are. So AI is really good at that. And this is what I think when I talk about how I would use AI, is that I would assume it's a junior engineer. I give it the logs in a structure, in a file, then it figures out what might be wrong, then tells me which part in the application needs to be fixed, and what I need to do to fix it. And then say, yeah, it's AI, why not? Let me just ask it, get the repository and ask it to fix it and create a pull request. So this is how I would do it. And I think DevOps engineers, quote unquote, or cloud operations engineers are well positioned in this AI transformation because they know how to go up and down the stack, and AI can be a force multiplier for them. This is how I think about how to use it.
Renato, you're on mute.
Thank you so much, Mallika. Sorry about that. I was saying before proceeding and keep discussing the topic, I actually noticed a super interesting question from the audience, from Gabriel, that is asking, when discussing AI, stakeholders often think about just generative AI. That's what you're thinking at the moment. And it's like, how can we clarify what we do in reliability engineering and SRE and better communicate the capabilities of AI? I don't know who wants to take that one. Martin, do you have any feedback?
I think there's a lot there. So I'll give you an example. So one of the first things we at Harness did for, with AI was more ML AI, and kind of, we have something called continuous verification. What that essentially does is it learns what good looks like for your application when it's deployed. So it learns that, you get these errors in the log, but you get those every time you deploy. That's not something you need to worry about. This is what the metrics always look like when you deploy, right? And then instead of, it doesn't alert you when those things happen. And, you don't have to have anybody watching it when you do that deployment. What it does instead is, stop you having to have people babysit the deployments and just tell you when there's something different from what a normal deploy looks like. Okay, so this is like, hey, you don't have to pay your engineers to work on a night after you've done deployment because you think it's scary, and they can just sit there and the system will tell them. And I think that's true across the whole thing, right? It's you can use it to actually solve real world problems. And I think especially when you're talking to leadership, you want to talk about outcomes rather than specific technical functionality. Hey, did you know we can be, we're generating loads more code, but we can't get it out because we're not generating enough tests? Well, actually, we can use help, we can use AI to help us build the gaps in our testing. The outcome will be that everything we deliver will be more reliable, and we'll actually get more of that newly generated code from our more productive engineers actually out to production safely and reliably. And that conversation up then becomes less about I can do these cool things to here's an outcome that happens because we're leveraging AI, whether that's generative AI or just straight AI, machine learning, processing of data.
Thank you, Martin.
Yeah, maybe I want to chime
Go
in
ahead, Patrick.
in that, the machine learning AI, used to sometimes refer to as the AI ops, was the predictive thing. It was the time series. It was like the trends, as Martin explained. But what we were lacking, if we were seeing a trend, we didn't have automation that could explain it, right? And that's kind of where the Gen AI comes in. It kind of can explain it, can triage it, can look for context, can look at our runbooks, and things like that. So a lot of people expected Gen AI to also understand the time series. I don't think that is the application of it, but kind of if you need more contextual explanation, that's where you put the Gen AI in there. So everything like we discussed, the triage, the filtering, the explanation kind of is more on those pieces as well. And maybe one last thing that I wanted to add is we think a lot about triaging, and Olalekan has kind of explained that, we might ask things to fix because it now understands our code, and that's also part of the context that we give it. So it's not on the predictive side. What I've seen kind of like used more and more is that we also use it for hypothesis building. Like, give me 3 options of how you would solve this. Give me 3 options of why it will fail. So that's another way you could leverage for your SRE solutions, in a way that it helps you actually through the whole process of like finding the solution, creating options, and going from there. And that's really powerful. And that didn't exist before with the kind of more machine learning aspects of it.
I kind of love that because that's a great description of the evolution. So going back to that original example, that the one thing was finding the signal from the noise, right? And that's what machine learning AI was really good at. But now you can find the signal from the noise and actually get something meaningful out of it that says, hey, I've looked at the signal from the noise. Actually, I can see from all the context that I have that this is where you should probably look, and here's why I think you should probably go here to fix this thing. So I think that's the evolution, right? The first one pointed you to say there is a problem, and now you can say there's a problem, and here's some ideas of, given everything I know, how you might solve that problem. And what you're doing there is you are saving so much time. That is the difference between a 1-day outage and a 30 minutes outage or a 5-minute outage, because you're being helped along the way. And the other stuff that Patrick was talking about there, if you've got your AI and it's listening to that Slack conversation that spun up for the war room because you have an outage, and it's summarizing everything. So if you come in after the call's been going for 10 minutes, you don't miss anything because it's already summarizing it, and it's making hypotheses along the way based on the conversation that's happening and all the data that it has and all the context that it has. I think it is an exciting revolution. And as somebody who in the past has been in those those rooms, sat there for hours trying to solve a problem, working out whether rollback is the better, solution and whether rollback was even going to work. I find it genuinely exciting, the evolution that's happening and there's been so much noise about the code generation, but there's so much more in the software delivery lifecycle that can be addressed.
Thank you so much, Martin. Actually, that raised two questions on my side. The first one is, I love the idea, but if I think from a team, from a personal perspective, that maybe you have just started or you have just that predictive part based on more traditional ML or whatever, how do I mean, where should I start? How can I do it incrementally before going full automation? Because it looks an amazing thing, but it's like, okay, I have my environment now with some alerts, something running there, my team that is on call and whatever else. What should be the first step? Where does actually AI save time and reduce somehow pain before really talking about that kind of full automation that is giving me all the advice and everything else? Where should you start? I don't know. Lekan, do you have any suggestion as a first?
Yeah, I do. I think Mallika wanted to add something and then I go after. Is that okay?
Yeah, sure.
No, yeah, I'll tie the two pieces together from the previous question as well. So for teams starting out, I really do feel summarization and correlation and not just automation, like Renato pointed out, is a great starting point, right? Because in my head, and it goes back to the question from the audience as well, if we are owners of reliability and so much about operations is an organizational problem to solve, right, and not just a technical problem, I do feel like if the goal is to have better impact assessment, then we need to focus before just the prediction and the remediation. We need to have a very good view into who is affected, who are our customers, how badly, and how bad is it when it's compared to the baseline. So if that's our goal, I do feel like if AI, our LLM workflows, our agentic workflows, if they can write a first draft of incident timelines, right? Like what happened, correlate the logs to the deploys, or maybe even just summarize what changed in the last 24 hours, that would build a lot of trust with stakeholder teams and with partner teams, because a lot of this is also not just a handoff, right? It's a continued partnership around how do we solve for incidents, what happens after, how do we recover from it, and then how do we prevent these kind of things. So I feel like teams build faster trust when AI explains what it's seen in the past before it's allowed to actually act. So building a path for that and having that journey is a better organizational framework to solve for. Ola?
Yeah, thank you. So I agree with you. I would just add to what you're saying, right? So I would say for transparency reasons, right, get your observability basics correct. So if you're using if you're in a large enterprise and you have multiple downstream systems talking to one another, get your tracing correct. So be able to trace across downstream systems, because then it's a lot easier to then tell the AI that system A, which connects to system B, followed through with this trace ID to identify where the errors are coming from the upstream to the downstream. And then to the point, it's the summarization of what might happen when you want to triage based on the trace. So this then is the next step. And for me, so that's a very, when you're working in with large distributed systems. For me, one example is how would I do it? And this is the question, Renato, you asked. So I would go through what I would do like as a junior engineer. So I receive an alert, I go into the log, I check the log, try to understand it, and then try to figure out in the code base what I need to do. And I model the AI, not create a model, but model the workflow with the AI to think through like this. This is how I would think about it. And then if this was taking me 15 hours, hypothetically, now I can get it done in 5 minutes because AI can do it. Then I think, oh yeah, let's figure out how to build this as a workflow or an agentic AI workflow. On a smaller note, so right now I was working on an let's say one of my private open source initiative projects, and something was failing in production. So what would I do? What I would do is go into CloudWatch, copy the log. I got an alert through CloudWatch alerts, went into the logs directly, just copied where it was failing, went into the code base and pasted it in there and said, to Patrick's point, hypothesis or what are the other ways to fix this? Put it in there, and then immediately it fixed it, created the pull request, and asked the co-collaborator to resolve. And this was in less than 15 minutes. This would have taken at least 5 hours, or if not more. So it's looking at how I would do it today, and I would hand that process over to AI, but still stay in the steering wheel to check if it is doing the right thing.
Thank you. I can actually, if I understand well what you are saying, is basically the build as well, the trust that we want to build with the AI recommendation is not really letting them take action. Is basically is the junior engineer giving me the advice, and then I react in much faster way somehow. I was wondering, when should you give them the power to take action, and what guardrail give you confidence to let kind of the AI run alone? I don't know who wants to take that one. Mallika, I see you smiling. I don't know.
I can definitely take that. So
Go, Patrick.
So it's a little bit of a trust maturity thing, right? So the first thing is, oh, I can read it. You give read access, they give you feedback, and you don't do anything. What is common in automation is that you then find like a workflow that you can kind of do a reliable thing, like react to something or a known state that you're actually acting upon. Now that kind of solves the thing about the Gen AI thing might not be deterministic, but the action it takes is actually deterministic. So it, like given certain criteria, it cannot do something wrong. So that kind of builds up that confidence to do it. Now I love that, like we were talking about, like building the observability and the metrics. Then making that workflow predictable is one thing, but I think we can also do a very good job at providing the agent the right context, what it needs to do something. So developers do this in their coding agents. They write their Claude MD, they give it context, and more context how to do things. Within ops, we have already a lot of that things in our run books, how to do certain things, our SLA documents, and we need to put in the work. We can't just say blindly to the agent, here's our logs, here's our process, figure it out. I know we're talking about the junior, but we have to onboard the junior kind of agent with all the context that he needs to make that decision. And that's also part of our job, I think, to make this trustworthy, like one that we actually provided the context that it needs to do, instead of it going like crazy, trying things out, going in all directions, and then kind of losing our trusts, basically. Martin, anything to add?
No, I do, and you're right in the same space as me, and it's funny because I think there's two things, right? I think it's almost like we're forgetting that, if you go back to traditional DevOps automation, there was this process of saying, I'm going to do this automation, and like you say, it's deterministic, but I'm still going to have somebody in that loop who's going to say it's okay. But then after you've said okay 1,000 times, that is just a waste of time, and then it just becomes fully automated, and you take if you like, you take the human out the loop for that.
I love the example.
And I do not think that it is any different with AI, right? You build trust in a process to the point that you don't need the human in the loop anymore for that particular workflow or process, because it's done it 100 times or 1,000 times, and you know what it looks like and what the outcome's going to look like, and you can say it's okay. But the thing I really wanted to pick up on is the context thing. You get much better results out of AI agents when it has a full understanding of your estate. Whether that is, when your artifacts were built, how they were tested, what your service dependencies look like, what does your documentation look like, you know, when were things deployed? How were they deployed? What are the open source dependencies that they have? What is your appetite for risk in the organization? What are your standards that you're trying to adhere to? You know, and so actually the interesting thing is that to get the most out of AI, you still need the good fundamentals in place to give it to it, right? If you were onboarding a new engineer and AI didn't exist and there wasn't documentation for all those things, and some of that knowledge was tribal, and you know, getting all of that stuff and those good solid foundations in place of this is how we work, this is what our estate looks like, having at least reasonably up-to-date documentation, you know, is how you onboarded junior developers and then you gave them tasks inside of that, you know, as per previously. You have to have that foundation to give to the AI so that when it's reading all those metrics and looking at the services and maybe looking at the outage and the logs and the, you know, and what's been deployed where and how those things depend on each other, you know, having all of that context available to it means that you get much smarter responses, and it ultimately accelerates that delivery that you're going to get and the time to value. But you have to have some of those fundamentals in place first. It doesn't, having Gen AI doesn't, and AI agents doesn't take away the need to put the fundamentals in place, you know, and
Yeah, and
yeah, go ahead.
no, you just touched upon something so interesting, Martin, and I do feel like that trust is earned through explanation and not just accuracy alone, right? And I was smiling before, Renato, because we learned this the hard way in one of the systems that we built, where it was a very large distributed system, and we used AI-driven analysis to support canary rollouts. And the model would flag elevated risk based on subtle metric shifts across regions, right? We were deploying it across regions. But early on, we noticed something interesting. The AI consistently missed failures that only showed up in our shadow canaries. So it was very interesting from a deployment traffic shape perspective, where based on the traffic shape and I think even the percentages, the downstream dependencies didn't fully mirror production, right? So the issue wasn't the model in this case. And the important point is that it was assumption mismatch, right? So it was reasoning correctly over incomplete reality. And to Martin's point, that goes back to the context, right? How rich is its context? And the trust breakthrough did not come from better models. It came from changing the operating model itself. We made AI recommendations visible before we took any actions. We required it to cite signals and restricted the automation that we were doing behind the scenes. And only when we were able to answer the question, if engineers were able to explain what the AI was doing, that's when trust started building. So, yeah, so that was a lesson learned from the trenches, I guess.
I do love that, and I do agree, by the way, that having the explanation of why it's doing it is super critical. And even if you're looking at something like, I know, there's a security vulnerability that's been identified, and it says, I know how to fix this in this code, right? It's great that it can do that, but you know, you want it to create the PR with the explanation of what it's doing to fix that security vulnerability in the code. You don't just to say, hey, I'm fixing CVE, blah, blah, blah. You want to say, I'm fixing CVE, whatever, and this is what I've done to fix it, and this is why. And then when somebody comes to review that PR, they can say, okay, that makes sense. The code looks correct. Great. Approve. And then it goes into the flow. You know,
I actually raise you on that one, Martin. So you're doing it in the CI/CD loop, but what if we take all the context that we've written in our run books and all kind of our knowledge that we have operationally, and we actually like plug that into the coding agent of the developer itself? Then we'll actually almost shifting left with all the operational knowledge, and we keep that up to date and kind of prevent it like even earlier. Anyway, so like that context and sharing that context across the org. Anyway, that's the power that I see that we didn't have before, maybe with DevOps, and it was also hard to get the incentive for people to do context beyond their own kind of piece. But now it's useful for yourself, and the side benefit, it's useful for everybody. Like how many docs went out of date, how many run books were not working, And now it's like,
Yeah,
because we're
Reynolds.
working on this all together, it stays in a much better shape. So
I think you're
Yeah.
100% right. I love it. So one of the examples I often give is that,
Mhm.
if I'm an engineer and I'm writing some code and I need to know something, it might be great. You might have some kind of internal developer portal or wiki or whatever it is with all that information. What I really want to do is just be able to type into my agent that sat in my IDE with me and say, hey, can you just get me the documentation for the API for our authorization service and tell me how I get a new token or how I refresh my token, for example. I'm picking a random innocuous thing, but being able to do that in the environment and get the response and not having to context switch out to go to wherever that documentation is, find it, look it up, and then context switch
It's
back
pretty powerful.
is a real accelerator, right? And it might be a 1 minute accelerator, but a 1 minute, 100 times across 10,000 developers in an enterprise is a massive time saving.
Lekan,
Yeah.
see, you wanted to add something? Go ahead.
Yeah, I think the context topic is good, but I also assume that we're overlooking the fact that these models have become really powerful. And towards last year, I think in the beginning of last year, we usually had maybe 5,000 word context or maybe 20,000 word context. Now the models are so powerful that some of them have 1 million tokens that can maintain context, which is what a lot of topics shifted from RAG into context engineering. And usually how I think about it is that if I'm going to triage a repository that I don't know anything about, how would I start with? It's how do I get an understanding? So the first prompt, in a practical sense, is get an understanding, a detailed understanding of this repository, as much as you can. And this is the prompt I type in my IDE to the LLM, and it goes as much as possible to get context of what the repository is, and that is the first context, is the code. Now, if you are skilled enough as a let's say DevOps engineer on SRE, you can also build your own MCPs, model context protocol servers, which can connect to where your repositories are, where documentation lies. And then in addition to in the local context from the project itself, you can get context from Confluence or whichever documentation that you have in there. And that also helps the AI to build context. And then it has better understanding of what it needs to do to resolve. If you're also skilled enough, you can, depending on the observability tool you use, you can also have an MCP that connects to your observability tool. And that also gets information about the time series of what happened or the series of events that led to the issue and the outage. My ultimate view is that in the AI transformation that we're in right now, I believe strongly that DevOps engineers are in the best position because they know how to make things work in the cloud.
That's an interesting take. You actually, before going to the next question ahead, I want to remind our audience to don't be shy, ask questions in the chat. I'm really happy to take them to our panelists. And yeah, so far you have basically killed one of my dreams. I always thought that whatever problem I had, one day Gen AI and whatever in DevOps would have solved it. It's very clear to me now that if I have a poor legacy bunch of bash script to manage my environment, there's not going to be AI solving that for me. I still need to document it and action properly to get it working. Anyway, going back to our problem, I was thinking, okay, so far I bought the idea that I can do, AI can help me at least, or I can help me sort out that outage at 3 a.m. But the question I really have now is, which decision should never be automated. You should never let AI do to manage that outage. So I don't know who wants to take that one. Mallika, do you have any suggestion?
Yeah, so for these 3 a.m. Incidents, breaks, right? I do think like automation is great at speed, but humans are still responsible for creating that meaning right? So that's around how I think about this problem. So at 3 a.m., machines should gather and be able to correlate, reason about that overall context, and humans should be able to decide under uncertainty. And those two things are very uh, separate, right, when an incident strikes. And in a high RPS system, we actually saw incidents where latency slowly crept up around our systems. Blast radius was very big. Our abstractions were questioned across multiple services, right? So, and the AI agent could quickly correlate some config shape or a partial rollout or a subtle downstream queue buildup in minutes, not hours. And this is what Ola was highlighting as well. So that was hugely valuable. And but what the machine couldn't decide was the intent, or what was the goal, what was the mission of this service. So, do we roll back and risk losing a critical fix? Do we shed the load of a particular region and protect it? Or do we accept some short term fixes so that we can have more time to recover from the incident? These are the value laden decisions, I feel, that need to have some human in the loop to handle that uncertainty and still do right by our SLOs, SLAs, so that trust in the system is still retained. How do we encode customer promises, business priorities, that risk tolerance? I think it's somewhere a blend of how much do we use AI to automate and have that human in the loop for decision making on the high leverage points. So that balance is where I'm kind of hedging on, but interested to hear what the other panelists think.
Yeah,
Guys. Sorry. Go ahead, Martin.
no.
Patrick,
Okay.
I saw Patrick nodding, so I was wondering if you had any.
Well, it's to me, it's a risk game, right? Forget AI for a moment. We were just doing plain DevOps automation with the pipeline and reacting to some of the monitoring that came around, even not predictable monitoring, but like known states. Would you kind of have a system reboot automatically? Or would you restore the database automatically? Now, it all boils down to how well is your procedure? How predictable is it? How much of the known states that you can do? So if you know exactly what the known state is, that helps you and you're able to automate that, whether without or AI or not with AI. Now, imagine you don't trust the AI to make the right call. Then you have to think about, okay, it's making the wrong call with this. What is kind of the impact of that? And do we have a mitigation on rolling back or not when actually stronger things happen? We cannot prevent everything. We cannot react to everything. So we'll have to find a middle ground of saying, well, this is a known state, we're reacting like that. And then kind of, if it goes wrong, we just need to make sure we have a system. Now, I do acknowledge in many environments, that is a hard thing to do. And you might have to re-architect for allowing that failure to happen to kind of take that risk. And that's why a lot of people will still watch babysitting kind of the alerts, but it kind of is about you putting in the work to say, this is maybe like a separate service. This is maybe like the impact we can roll back. So we have a mitigation for that, or like anything to mitigate a risk that kind of says, I'm okay with taking the risk because I have actually mitigated the impact on that. And it could be data, it could be customer failure, it could be various things, but that's kind of how I think about it. And that's a lot of people talk about the undeterminism, and that's great, but you can have undeterminism because that's production basically. End users are undeterministic on what they do. So you design for the same thing actually to be happening if you're doing your architecture right.
Yeah.
Thank you.
Yeah. I mean, I feel like it's, I think if I was summarizing from both of you guys, my view is, and I think my view is aligned with it, the machine can genuinely help, it can correlate, it can summarize, it can suggest to, known run books or, and potentially, I think especially if you've built resiliency testing into your release process, if see something it knows how to act on, maybe a scale up, maybe a rollback, maybe a flip a flag in known safe actions, then I think it can do those things. But then equally on the other side, I feel like, the humans there to kind of make those decisions that have an impact on the customer or the business trade-off, the SLIs, the SLOs, the risks associated with that. I think also they own anything that might be an irreversible change, maybe a data migration or a destructive operation, and ultimately they're the human needs to be the person that's, ultimately saying, hey, we need to escalate this up and let people know that this is happening. They're kind of that decision point for that. And again, I think ultimately it's that interpret the nuanced business context, right? That isn't necessarily codified into any run book or something that the AI can just read and do. So I think there's like that split between, hey, here's a bunch of things the machine can do and can do really well, but here's where the human needs to be there because the machine doesn't necessarily understand or can make those decisions and can't be accountable for some of those decisions.
Thank you so much, Martin. Actually, there's an interesting question from our audience that I don't know, maybe Elesin will want to answer it. I don't know if you read it, but just to take it back, what would be the best approach around creating an AI strategy so that stakeholders were skeptic around the adoption of AI for DevOps workflow can buy into the promise? What will be the key pillars to have in place before adoption can begin?
Okay. I read the question and thank you for reading it out so that everybody hears it.
Sorry.
And it's an excellent question. Good. But I think I like the fact that you read it out. To be honest, the answer of the question to the question is inside it. So how would you create in crafting an AI strategy for DevOps workflows? I would really take that and put it in our internal AI tool and ask it that question. This is my starting point and give it the context of my organization to see what do I need to do to convince my stakeholders. And I do this a lot in crafting anything, any documentation and saying, what do we need to do? And this is the starting point. This is how I will start it. This next point is in editing that information or aligning it into the organizational context is the stakeholders really well. You've been in conversations with them multiple times. What do they really care about? Is it and the starting for us, where I work today, it's working backwards from the customer perspective. What value are we trying to create for the customer? And once you have that nailed, also provide that context to the AI as well to refine your prompt and to refine the output. Once you get to what it looks like, talk to the first and most important stakeholder in there. And this is how I drive organizational change, because what you're talking about is not an AI strategy in itself, is how do you drive organizational change around leveraging AI for DevOps workflows. Once you get the buy-in, talk to them individually and then talk to them collectively. And maybe in the discussion, you have a simple proof of concept, which you can also build with AI, right? So you can say, today, one of our most recurring incidents is null pointer exception in a system that nobody knows about that was built 7,000 years ago, right? That's an hypothetical example. And then you show how you use AI for let's say, after an alert comes in, summarization, show how you use AI to generate whatever it is, and then map out the workflow steps. And then show in the discussion the real value through a proof of concept and make it clear to the stakeholders that AI will take our MTTR, mean time to restore, from X days or X hours to Y minutes. And this is proven in this proof of concept, hypothetically. And this is a more convincing discussion than, we have an AI strategy and then nobody can really bring it to reality. It's not, you cannot connect to it.
Thank you.
I love that. And I just want to also quickly add right around what Ola was mentioning, as I think especially around those skeptical stakeholders, right? I found it very useful to anchor it in outcomes rather than capabilities at that point of time, because having that clarity changes from why to how. So instead of starting with, oh, we're building a AI strategy for DevOps, let's say, right? Maybe starting with something grounded and concrete, like maybe the main customer problem is to reducing mean time to understand incidents, or we have bad customer minutes, or unsafe rollbacks, and having a strategy around it or a way to think about it is a good starting point, because that grounds the conversation and drives that alignment. And I typically have seen skeptics buy in when AI is tied to a metric they already care about, right? So starting with that makes some progress. But yeah.
Yeah, I like
Mallika.
the way that you frame that. Like, if they feel a pain, then you can come with a solution. Basically, that's what you're saying. So if they don't feel a pain and you're just saying, here's a hammer, like, they wouldn't care. You can't sell that. It's like, it was early days DevOps, the same thing. Well, why would I do DevOps? Well, you don't have this problem. Well, I don't care. So it's hard to sell if that is not a problem. Now, today, maybe you don't feel the pain in your company and you might not care about downtime and you're still selling to your customers. But guess what? In years, 2 years, your competitors will be, and they might give a better service and they might do something. Now, some kind of domains are maybe more immune to this, but it's kind of like tap into a pain, because then they'll listen to you. That's kind of my learning over all the years of DevOps. And don't come with the solution, but actually solve their problem that they need. So,
Correct. Just to add on the strategy, right? I think if anybody's the person that's asked the question, if you're thinking about strategy at all, I would say read a blog post on Good Strategy, Bad Strategy by Richard Reynolds. It's a good one. And in frame, it talks about the diagnosis, the guiding policies, really understanding the pain that exists, or not invent a pain that you think is your pain, but invent the pain that is relevant to the customer, relevant to the business. What are the guiding policies that you want to put in place, and what are the coherent actions, and back it up with a proof of concept. And to the point of Mallika, is the most important stakeholder who feels this pain the most in the business, and then start from that person.
Thank you. Actually, I have a different question. Last week, I read an interesting article from the team at Google that they explain how internally they use for their SRE generative AI. Of course, what they use is pretty obvious because they're Google, but they basically describe the entire process. I can share the link as well for our audience, so everyone can have it. They basically define 4 different areas. One was the one we covered early, like the 3 a.m. paging, then the mitigation phase, the analysis, the root cause, and finding the root cause of our problem, and then as well all the post-mortem with the incident rep or whatever. And they cover how AI can help in all 4. I was wondering if any one of you is actually, do you all agree that you need AI on all those? Do you actually need it certain? Do you use it everywhere? I don't know, Martin, what's your feeling about that?
Across all the 4, I would say yes. Basically, you can use it. So, if you're, so paging, yeah, agents, they can help, duplicate, they can, route intelligently, they can include rich context, with that alert. I think they can help in mitigation. They can give like well-defined kind of reversible policy governed actions that are safe to kind of autopilot, for want of a better phrase, for known scenarios. They can absolutely help you come up with your root cause analysis. They can look at all of that data, look at the kind of timeline synthesis, and create those hypotheses of what is the likely root cause. And absolutely they can help in the post-mortem phase too, right? They can draft the initial incident report. They can pull the relevant metrics and context, and propose follow-up action items for people to actually do. So I think I guess my red line is that agents can assist in all of those phases, but accountability and the final decisions still need to stay with humans. You can't make the agent accountable. You're accountable. if you see what
I like that as well. I also agree with agents participating in all four phases, but maybe not owning all four of those phases, because participation and owning are two different things. So, for example, paging and mitigation benefit enormously from speed, velocity, how quickly can we come to a point of alignment, right? But root cause and postmortems require more narrative, accountability, to Martin's point, and just that learning that comes from deep, rich context. So AI should accelerate that learning, but I don't think it should absolve teams of that understanding, because that's the opportunity for the teams also to build that maturity over time.
Absolutely, 100%.
I can add one thing is that most companies are not, or most people on the audience right now are not working at Google. So how do you start, right? And I think one practical experience I learned is when we have postmortems, or when I run postmortems, I always try to record them. And then I take the transcript and give it to our internal AI tool to convert that into the postmortem documentation. And it can do a whole lot of good, because then it saves me a lot of time in trying to synthesize the time series of how events happened. And I think this is a great way to start. Secondly, is also sometimes it's not only on the call, it's also the chat correspondence as well. You can also take that and put it as well into the AI or the LLM that you're using within your organization, so that it's not leaking data out, to generate the sequence of time series of events that as it happened and how it was resolved. For me, I found this very useful, saving me hours of time, and I translated this also to my colleagues to to save time in postmortem documentation.
Thank you so much. I love your advice, your action items somehow. But as we have just really few minutes left, 3 minutes left, I would like to close, giving the chance to each one of you to give some advice. Like, okay, I'm a DevOps engineer. I joined the roundtable. I have some experience with AI, but I haven't actually done anything in terms of using agents in my DevOps deployment, production, whatever. I want to start tomorrow. I want to spend a few hours doing something. What's the first step I can take? What's some advice? Can be a book, can be an article, can be an agent, can be a test, can be, do a transcript of the last postmortem. I don't know who wants to start. Martin, do you have any advice?
Oh, okay.
Something that can be done in a short term, not like move everything tomorrow, but something concrete that could be done in a short term.
I like, if I'm sat there and I'm a DevOps engineer or a platform engineer, I would literally, and this echoes to what we've, I would find the thing that causes me the most frustration and see if I can solve for that. Like, if I genuinely, I would find my personal frustration and solve for that, and then say, okay, it can help me here, and this is how. Now, how do I codify that and make it work at scale, reliably, and trust? And in terms of like something to read or do, the side of the question, I will, and blatant plug, we have a DevOps modernization virtual summit coming up. Absolutely 100% free to attend. We have Anthropic are there, United Airlines, Google, AWS. We have Matthew Skelton, the author of Team Topologies, at that. I would recommend you go see our DevOps Modernization Summit.
Thank you, Martin. Mallika.
I'll keep this one really simple and hopefully actionable. I would say just pick one painful operational workflow that happened recently and try to make it explainable. For example, it can be something like what happened in the last incident, why did we see this SLA breach, what happened in our system. Start from that question and then use AI to auto-generate timelines, summaries, how did the deploys happen, and tag signals as we are going through that workflow, and don't automate actions yet, right? But if we can start with automating that understanding and then automate the actions, maybe that's a good place to start. Very simple and hopefully actionable, to start tomorrow.
Thank you, Mallika. Elesin, we have really 30 seconds each because we are really running out of time today.
No problem. Sure. I would say the same as Mallika said. Download the logs from your CI/CD pipeline. Download the logs, put it in a markdown file. Download the logs from your production environment where you observe the failure, put it in the markdown file, fire up your IDE that has the LLM in there and ask it to go through both files and tell you why the incident happened, what happened, and then get insights from it. That's all.
Thank you so much, Patrick.
Yeah, I'm gonna give an odd advice, is use one of the chat solutions like Claude and so on, not maybe in coding, not in your IDE, and start by learning how to ask it questions and correct it. So they're really powerful in the way that they kind of learn from what you want, how you want it. So the more time you spend, the better results you get. And you take those learnings and actually put them in the context while you're doing your job. And anyway, that's been proven quite powerful for me, at least.
Thank you so much, Patrick. And yeah, we have reached the end, unfortunately, of the time for this session. I see as well there was still a question in the audience about the environmental impact of agents, and I think we could have a full session on that. That's another interesting point we should cover at some point. Heads up to some QCon conference. There's London coming up this spring. Some panelists from this today, Patrick is going to be there as a speaker. And there's as well QCon AI in Boston and QCon San Francisco, of course, later in the year. But thanks again for the panelists, and thanks to our sponsor, Harness, for sponsoring this session, and have a great rest of the day. Thank you and goodbye.